We'll start with a deliberately unsafe agent. Too trusting, too connected, and missing basic guardrails. That gives us a clear baseline. As we harden it, you'll learn how to spot risks, document them, and turn weaknesses into security controls. So far, we've seen why AI agents introduce new risk. They reason, use tools, access data, and behave less predictably than traditional applications. We then used threat modeling to organize those risks. Now we'll turn that thinking into a deliberately vulnerable agent baseline, which we can inspect, test, and later secure through least privileged tool access. Before we harden an agent, we need something concrete to harden. A vulnerable baseline is a safe, controlled version of the system with key safeguards intentionally missing. That makes risks observable instead of theoretical. Learners can see prompt injection, excessive tool access, data leakage, and weak logging as real failure modes. Later, when we add controls like least privilege, approval gates, logging, policy enforcement, and governance, the improvement becomes measurable. The baseline gives us repeatable labs, clear comparisons, and a practical reason for secure by design choices. Our baseline agent is capable, but intentionally unsafe. A user gives it a natural language request. The agent interprets the task, pulls context from internal documents or a vector database, and takes action through tools like email, file access, ticketing, or web requests. That combination is powerful because the model can both read information and change external systems. The weakness is what is missing: strong permissions, instruction verification, tool guardrails, and checks on whether retrieved content should be trusted. This baseline is vulnerable by design because we want failures to be observable, repeatable, and teachable. The risky defaults are familiar: too many tools, too much trust in incoming text, too little evidence after something goes wrong, and no human checkpoint before sensitive actions. Each choice expands the agent's blast radius. A harmless request can become a database change, a malicious instruction can override user intent, and a failure can leave no clear trail. As we harden the system, keep comparing each improvement against these unsafe assumptions. One major weakness is broad tool access by default. If the agent can read, write, send, delete, and modify without tight boundaries, every reasoning mistake becomes more dangerous. The issue is not that these tools exist. It is that permissions are not scoped to the user, task, session, or risk level. The model may decide to call a powerful tool with no separate policy check. If the agent is manipulated or compromised, legitimate tools can become the path to unauthorized access, unintended messages, data loss, or system impact. In an unsafe tool execution flow, the agent treats a request as permission to act. The prompt enters the reasoning loop with little validation. The model then chooses tools based on its interpretation rather than a strict policy. Tool results may be fed back into the conversation as trusted context, even when they contain errors, sensitive data, or malicious instructions. The highest risk comes at the end. Actions can run automatically against real systems, such as databases, email, storage, or third-party services, without authorization checks, approval gates, or output filtering. Sensitive context injection occurs when an agent receives more internal information than it actually needs. A prompt may combine user requests, system rules, retrieved documents, tool outputs, and memory into one working context. If that context includes secrets, customer records, or operational notes, the model may accidentally rely on them, repeat them, or expose them in a later response. The risk increases when retrieved documents contain stale or malicious instructions, because the agent may treat them as trusted context. The key control is need-to-know filtering before information ever reaches the model. Retrieval is often treated as a relevance problem, but in enterprise systems it is also an access control problem. A vector search may find a highly similar document, but that document may belong to another customer, project, role, or sensitivity class. If the agent retrieves from one mixed pool, public FAQs, internal runbooks, confidential records, and restricted incident notes can blur together. The fix is to enforce authorization, classification, and tenant boundaries before content reaches the model. Similarity should decide what is relevant. Policy must decide what is allowed. Prompt injection happens when untrusted content contains instructions that look like commands to the agent. An email, ticket, Web page or document might say, ignore previous instructions or use this tool now. A vulnerable baseline retrieves that content, mixes it with trusted system instructions, and fails to label the difference. The model may then treat the attacker's text as authority instead of data. The risk escalates when tools are available because confusion can turn into searches, messages, data access, or actions that carry the attacker's intent. Strong agents must classify inputs and enforce instruction hierarchy. Identity has to travel with the request. When an agent receives a user request, it should carry that user's identity through every tool, API, and data access decision. A weak baseline often breaks this chain. The agent may switch to a shared service account, so downstream systems only see the agent, not the person behind the request. Then role, group, tenant, or business context checks can be skipped or applied in the wrong place. This creates two risks. Users may access or trigger things they should not, and audit logs cannot prove who actually caused the action. Automation also needs checkpoints. When an agent moves straight from planning to execution, small misunderstandings can become real-world changes. Sending messages, deleting data, updating records, and launching workflows should not all be treated the same. The system needs to classify risk before acting, and for high-impact actions, pause for human review. A clear preview matters too. What will be changed, who will be affected, and how to undo it. Without that checkpoint, accountability gets blurry, and automation can repeat mistakes faster than people can catch them. Logging is more than an operations concern. It is the evidence trail for security. If the agent records only a final response, investigators cannot reconstruct what prompt was used, which documents were retrieved, which tool was called, what arguments were passed, or why the action was approved. That creates ambiguity during incidents. Was the cause user input, model behavior, tool misuse, or exposed data? Secure agent workflows need correlated telemetry across the session, model, retrieval layer, and tools so teams can audit decisions, respond quickly, and improve controls over time. Before hardening anything, capture the baseline in a way you can test later. Record where prompt injection can influence the agent, where authorization is missing or inconsistent, which tools are too broadly permitted, and what evidence is unavailable when something goes wrong. For each item, note the current status, the risk, and the module that will address it. This turns a vulnerable demo into a measurable security plan. As the system improves, you should be able to prove exactly what changed and why. The key lesson is that agent risk becomes manageable when it is made visible. Broad tools, sensitive context, weak input handling, and limited oversight create the vulnerable baseline. Controls like data boundaries, authorization checks, approvals, and audit trails turn that baseline into something testable and measurable. Next, we focus on tool permissions and least privilege as core security boundaries.